Okay, here we are. Here you are. Thank you for joining the session. One of the last talks of the second day. You're still going strong. That's good. You know, there are two kinds of speakers. The one that they speak more quickly than they planned when they rehearsed, and the other when they use more time than they planned. So I hope to be in the first group so you can get to the fun part in the expo area. I'll give you motivation for doing this talk. Perhaps you can relate to this situation. A senior developer in a team greets a new team member, presumably a junior. Now, a junior usually don't have all the history, so they are free to ask all the questions. So why do we need this? Why do we need that? Can we skip this? I don't understand. This is complicated. And then you answer it with all the arguments of scalability, complexity, organization size, quality, whatever. And junior, not being so versed in the terminology, accepts or seems to accept our arguments and start the work, do the work the way you recommend or the way you require. I don't know. But when you go home, and maybe in the middle of the night, you wake up and you start to ask the same questions yourselves. Do we really need all these processes, best practices, structure, bureaucracy? And now, that was the question I asked myself. And there is this nice story for all the senior developers out there. We go back to Brunswick, Germany, around 1785. This is supposed to be the true story. Now, this is a bunch of 8-year-olds in a class. And we all know the 8-year-olds in the class don't behave like this. They usually behave like that. And what's beautiful about children, that no matter how many technology advances we have provided the last couple of centuries, they still behave like this in school. And now teachers have different ways to employ to keep them more silent or to make them do their tasks. So the teacher in the Brunswick, Germany, back in 1785, gave them an assignment. It was a math class. So can you add up all numbers between 1 and 100? And it provides some impact in that very situation. So the children start doing this. 1 plus 2 is 3, and 3 plus 3 is 6, and so on. Now, this is my handwriting. I finally found a story where my handwriting resembles the story. This resembles the handwriting of 8 years old. My handwriting never proceeded about that. So on. So how far they can get. And they all work quietly except for one 8-year-old back in Brunswick, Germany. 2 minutes just after the assignment was given, that one particular 8-year-old goes to the teacher and provides the answer. And the teacher is astonished. Did you actually manage to add up all the numbers in 2 minutes? No. This particular 8-year-old saw a pattern and added first and the last number, then the second and the second to last, and 50 times multiplied and got the result. Talented 8-year-old. Of course, at that very moment in Brunswick, Germany, the formula for arithmetic series was invented or discovered. Depend how you look at the math. And that was, of course, some of you know, this is supposed to be a true story of one of the most famous mathematicians of all time, Carl Friedrich Gauss. Now, I'm going somewhere, believe me. So, as a senior developer, you want to have a legacy, you want to be remembered as a teacher or a mentor for the next Carl Friedrich Gauss, not the one who tried to restrain the genius with all those practices and processes and structure. So instead, you should give them an assignment and join them to see how juniors solve the problems. And that's what we did. Me and my colleague decided, okay, next project we're going to do, we're going to question the very principles we hold dear. So the goal of this talk is to provide you with a set of questions. No more, no less. To be applicable in your context. And I just fast forward to those questions. We skip everything, go straight to the questions. And these are the questions we arrived to. So do we really need, or how much of domain knowledge do we really need? In every case. And when we make a choice of an architecture or architecture style, what justifies that choice? And the last one was, put yourself in the perspective of a code reader and let that guide your decisions. How much of a cognitive load is required to understand and comprehend the code? And the way we did that is that for many times we got critical questions regarding the methods and principles we valued. So let's use the same critical questions and try to answer them in a more balanced way. So one of the typical critique of domain-driven design is, I don't have time to do domain-driven design. Okay, that's fine. So, but what we arrived at, it's not about how much time you spend, it's how you test your models. So can you test them in a more pragmatic way? And accepting this fact, which is actually was in the original book on domain-driven design, if you just read carefully enough, accepting the fact that not all parts of the system will be well designed. And then, how do we know we chose the right architecture or architecture style? Well, you need some feedback on that. You need some feedback loop, and the complexity gives you feedback. So how do you work with complexity? Gives you feedback on your choice of architecture. What about test-driven development? Everybody likes to discuss that. You don't need it everywhere. I agree. We don't need it everywhere. It's about your confidence. And that's where the code reading comes into play. If you can accept a certain level of cognitive load when reading code, maybe you don't need more tests. Let's get back to that. And my personal part in all this was that while I'm working as a consultant in this small consultancy here in Norway called CoreWork, where we do a lot of domain-driven design, somebody along the path tagged me as a domain-driven design enthusiast. Oh, that was fine. But then maybe I need to question the very principle of domain-driven design if I want to teach it and use it regularly. So that is what is this talk all about. So now we are starting the story for real. This was a real-life story, so I'll try to present it as many details as possible for the purpose of this talk. If you have any questions or comments, please use Menti. I'll get back to you, answer it on the Slack channel of the conference. I'll try to provide answers as soon as possible on my LinkedIn account and on my blog. So please engage. Every feedback is encouraged. So this talk will be in 3 parts. So we'll try to first the question, domain-driven design and its usefulness, deliberative choice of architecture, and test-driven development. See where it leads us. So 3 parts today. Let's start with the first one. How much domain knowledge do you really need to get the work done? So this was a real-life story, so I'll present you the real business context. So a client approaches us, me and my colleague, and presents, I need a system support for this. In case of an emergency, if all traditional communication channels are unavailable, I need a way to communicate with my employees, and I want to use text messages regarded as a rather reliable way of communication in the modern infrastructure. Right. Okay, that is the case. And we have this HR system that have all the data on employees, and can you connect this to some gateway for sending text messages? Well, this looks okay, doable, achievable. So me being domain-driven design enthusiast, I bring the blue book. Let's do domain analysis right away. So they need to understand the language, the needs. Through the language, we'll understand the needs of the stakeholders, and do not settle at the first model. Try different solutions to your problem. That's a really interesting piece of advice. And use the language to model your application, the language being the secret ingredient of domain-driven design. But then we agreed to question these principles. So, do we need to do it? How much of it is enough? Well, how complex is your problem? Okay, we can afford go back and have one conversation with our stakeholders. Let's do that. So we go back and have another conversation about the business context. And it turns out this emergency case, you can just forget about it. We don't need any system for a crisis or whatever. We just need you to focus on when your communication channels are unavailable. We want you to be able to distribute information to our employees. Okay, that simplifies things, right? And still we need this HR system integration, but this is not a problem. Part of the problem, this is a solution proposal, so we just keep it at bay a little bit. Okay, one conversation, we actually managed to lower the level of complexity. Less complexity than initially assumed. Not much of a domain language nuances here, right? Rather straight away. But there was this advice of not settling on the first model. Let's try to play with alternatives. Okay, let's do that. So let's just implement it as an intuitive or naive way to do it. Let's just, how would you do it intuitively? So we sketch something, and there we go. Beautiful. So we can have one application that can fetch all employees and phone numbers from this HR system, and then can send bulk SMS, Merry Christmas to everyone, through some SMS service. Perhaps we need a database to store some data in case this HR system is unavailable, because you still want to send Merry Christmas on 24th of December regardless. Great. That could work. But okay, let's try to listen to this advice of not settling on the first model. Let's try another model. Can we solve the problem differently? And of course, sending text messages is a solved problem. Many people have done it. We assume there is somebody offering it service, and it turned out, yes, there was this customized service for enterprises provided by a third party that can be operated by a user from our client that can send SMS message to all employees or only to some employee groups. Okay, so our application now is suddenly a batch job that triggers and fetches all employees and now updates the employee groups, meaning that we turn it a little upside down. Instead of sending the messages, we just prepare the ground for sending the messages. However, this model revealed something of a language that was hidden. What are these employee groups? What are they talking about? Didn't mention it at all. It turned out there was a rather interesting internal organization at our clients. They had the several sub-organizations, the employees contracted across the organizations, and people could be contracted several places and so on. So that structure needed to be reflected somehow in those employee groups. And we didn't understand this at the time. But it turned out a bit of the DDD inspiration was useful. We revealed the business model more clearly. Can we get even better with the third model? We could, yes, we can, I don't know, but we didn't. Why? At this time, okay, let's question, try to be a little bit skeptical. How can we deliver something more quickly? Do we need to spend more time on analysis and modeling, or can we deliver something? I had a great chat with Jason Gorman on Mastodon about this, and he revealed his technique. For him, like, deliver as quickly as possible what they want, and then you expose the problem. Expose the problem of the initial requirements, and then you iterate. When you have something concrete, then you iterate on that. So we decided, let's deliver the second model instead of going with the third model. So let's deliver it and see if it works in production, and then we iterate on that one. So we stop on the second model. Do I still have, I don't know. I'll speak as loud as I can. So it was not about how much time we spend on modeling. It's about testing your models. Can you test your models through delivery? I would recommend that. Otherwise, you test it through scenarios. You challenge the models through scenarios. But if you can do it through delivery, then you get some benefits. And you spare some time. So that was domain-driven design so far. How about the second principle? Deliberative choice of architecture. So we enjoyed using hexagonal architecture on several projects, so let's use it on this one as well. This is known as port and adapters architecture, and the intent of this was formulated by Alistair Coburn, who was behind the concept, talking a lot about isolating the application, being able to develop and test it in isolation from its external dependencies. Okay, so how can we isolate the application to be able to develop and test it in, without testing all the external dependencies all the time? Okay, so we drew another diagram. Hexagonal architecture requires some hexagons, right? So we isolate the domain model, we use dependency inversion to define some domain-oriented interfaces that were implemented by our external dependencies. That way, domain model does not know anything about external dependencies. Then you have some application service that kicks everything off. And so those interfaces we're talking about, in the language of the domain model, or the language of the stakeholders, we're talking about SMS messages and our employees. So we need those interfaces. Now, when you implement employee service, you get the HR system. When you implement this one, you get this third-party enterprise service. Okay, so this was a sketch. And how do we map that to the code level? So this was a Java application, serverless in Amazon cloud. Doesn't mean anything for the purposes of this talk. But we used the abstractions that were available to us in the programming environment. And in this case was namespaces. So let's use namespaces as an abstraction to create this isolation of the domain layer. So the application service, application layer got their own namespace. External services got their own namespace, this HR system and this SMS service. And the domain layer was isolated in its own namespace. And we created adapters that were implemented by external dependencies. And we tried to keep this logic for keeping this HR service and these employee groups that we didn't understand at the time in a separate place, a separate class. And now to enforce this, you need to manage dependencies. So we made some rules to comply with hexagonal architecture. Now, anything can depend on domain that cannot depend on anything else. So you want the dependencies to flow towards domain and not the other way around. So we enforce the architecture by managing dependencies. Now, how do you manage it in a daily work? You can, of course, do it through code reviews, but there are plenty of tools out there to manage dependencies, to verify fitness tests or whatever. Now, this choice had some impacts. We introduced several abstraction layers. We introduced rigidity and we require more discipline from developers. So these choices have some consequences. Is that okay? Are we okay with that? Shouldn't we question it a little bit? Especially, does the insight of business complexity justify this choice? How can we reveal the business complexity? We are still uncertain at this point in time what was the complexity in the domain. So the feedback on the architecture choice was through domain complexity. And it was all about this terms employee groups. We didn't understand it. What was this? What was the semantics behind? Now, we stumbled upon this quote from Dave Farley about evolutionary architecture, talking about when you don't understand the parts of the system, you abstract it away, one abstraction at a time. So what part of the system we didn't understand? That was this reflection of organization structure to those so-called employee groups. So let's abstract that away. And we did that. Everything that had anything to do with it, we put it in one place, one class. Keep these things in sync. Now, they finally talked about abstractions, and we can go head-on with all abstractions, what's called abstraction-first approach. Let's create all the abstractions in the code we need to solve this synchronization problem. Okay? So let's create something that gets employees' contract situation, reflecting the internal organization in the SMS groups, and let's synchronize it because all things can get out of sync. Employees can leave, new employees can get in, and people can change employees within the organization. So all those things need to be kept in sync. And since this was not trivial at all, keeping these things in sync, we decided to any inconsistency we need to report to some human user so they can take appropriate action. So we could have gone this way, created higher level abstractions in the code, following, there was some principle somewhere that code should be on the same level of abstraction, and hope that this would provide more readable, more maintainable application. Anyway, there was enough uncertainty and complexity that justified putting the business rules in one place. That was okay. However, we're talking about one abstraction at a time, not all abstractions. So that was what Dave Farley tried to teach us. Evolutionary architecture, one abstraction at a time. Do we really need the whole, all the consequences of hexagonal architecture? Okay, let's see if the third principle can help us answer that question. So, test-driven development. When and where to use it? Well, abstracting the parts of the system we don't yet understand. So we didn't understand this concept of employee groups. And whenever somebody or something or some project throws complexity at me, I try to respond in terms of examples. So the more complex the case, the more examples I need. And to the power of the examples, I try to understand the domain, the complexity. You could go the other path and try to understand it through rules. I claim to be much more challenging. So can we build our understanding through examples? Can we build understanding what are these employee groups through concrete examples? And that's where the tests really have a role to play. They can help you build your understanding one example at a time. And that's what we did. So all those edge cases, employee exists twice in same group with duplicate phone numbers. What to do with this one? Well, you don't add duplicate number. Some employees don't have a phone number registered. Okay, just report them. When you have two names, two employees with the same number, okay, what to do then? You report one member, and because the other uses the same group, uses the same number. Now, if you try to analyze the languages used here, we are approaching the language of a stakeholder. We are approaching the language of the business on test level, which brings kind of domain-driven design back into play. Okay, we decided to stop in the second model, not analyze further to the third model. We stopped the second model, started to deliver one, and then we are able to involve the stakeholders writing the tests with us, at least on the conceptual level, because tests speak the same language as the stakeholders, one example at a time. So test-driven development help us explore and learn, slowly revealing the complexity. So that was the real value of having tests and writing them test first. Now, what is the difference of going with abstraction early and just doing one example at a time? So I'm going to show you almost the complete code listing. It was this. Now, I don't expect you to read this, understand it, it's just a short time span we have. But one example at a time, we arrived at this one without too much abstractions. We could have added those abstractions, but do we gain anything by adding abstractions? And that's where this notion of cognitive load, by reading the code, is comes into play. How much cognitive load you need to understand the code you have in front of you. You know the situation when you try to understand the code and you have many abstraction layers and you start at the top and you have to step into the functions again. Finally, you found what you're looking for, then you have to go back and you have all these context switches all the time. It's really hard. So consider not introducing abstractions, at least not too early. Another thing is feeling committed to your abstractions. I was personally guilty of this in many cases. I was trying to defend my abstractions as if they mattered something. So try to, are you committed too soon to the choices you make, to the solutions you make? So in this case, one example at a time, we arrived at this. Now the functionality is still here. We still need to reflect your organization structure in SMS groups. We still need to synchronize, and we still need to report. However, we decided not to add, to keep code like this. Hopefully, this is, the assumption was this is cohesive enough. You need to understand, to read all of it, to understand the whole picture. Adding more abstractions would actually subtract from the value of the code. You would need more cognitive load to jump back and forth. One abstraction at a time, test first. Helping us modeling parts we don't fully understand. But does this justify the whole concept of hexagonal architecture? It was one area, particular area, that we struggled to understand, not everything. So in hindsight, I would say that this would be the best or better solution. The main layer is justified to have their own abstractions. And the main layer is justified to have strict dependency management towards the main. But then you could relax constraints on everything else. So perhaps just two namespaces, one domain and one called everything else, or something like that. So you relax constraints where you don't need to focus, and you impose constraints on the important parts of the code. And you let the rules, the rigidity, evolve in the team. Why start with all the rules about the way dependencies are managed, where you can let them evolve on those parts that are not as important or do not have the same level of complexity as other parts of the code. Which brings domain-driven design back into the play. That's what Eric Evans was talking about. Not all parts of the system will be well designed. We want to focus on the core part of the application. We want to focus on the part that matters the most. That's where we use time and try to create elegant models. For other parts, we just accept that they are not as well designed as other parts of the code. And you use tests to explore the domain. If you actually able to deliver, soon you're able also to use tests in, together with your stakeholders. So this communication between domain experts and technical people is more exposed when you have ability to deliver sooner. Okay, so what about test-driven development? Do we need it everywhere? Now, I have to admit that in the past, I was the one advocating for using test-driven development everywhere. We are professionals, we need to do it, we need to document it. And there was the same arguments that I just used, imposing the rules and structure too soon. So now, as I mentioned, we had this part of the code when we, after the synchronization between the employee service and the enterprise, this text message service, we had this part that there was some inconsistency in synchronization between those two systems. And now we decide to report those inconsistency to human users. So we used Slack as a way to report it to human users so they can take some action. Now this was the code that actually posted messages on the Slack. Now this is something else than I showed a couple of slides ago when I showed all this domain complexity. I would expect average developer, given a reasonable amount of time, to be able to read through this and conclude what is going on here without any other documentations, either in formal tests or anything else. So just code by itself, because the cognitive load here is not very significant. We can read it, we can understand it, we can have sufficient confidence level that we can maintain this and develop it further. And there was effort involved as well. Writing the test against Slack API was not trivial, so we should just forcing ourselves to do something that has less value compared to the investment in time. So whatever code you might call code on the edges or a standard code, perhaps you don't need tests there. Keep the focus on where it matters most. But use this perspective of a reader, code reader, as a guidance. So if you can read the code and understand it just by reading it without needing to argue too much back and forth what's going on, then it's okay to not have tests, perhaps. Okay. I promise not to keep you too much. So here in the basement or cellar, I don't know how you call it. So just to wrap it up. So those questions I suggest you consider when you have a problem at hand. How much domain knowledge do you have? Do you need? Perhaps delivering sooner can help you answer that question. You deliver, and then you try to understand, and you find out how much you don't know by delivering sooner, instead of assuming too much. Of course, it doesn't work everywhere. There are some projects where we can't do this, and where the level of complexity is unsurmountable at the beginning. But consider it. Can I deliver sooner to verify my model, but still not stop at the first model? And can you defer the choice of architecture? Can you do some hybrid kind of choice that we suggested? Like you isolate one part of the code, but you relax the constraints on the rest of it. So you have evolved the architecture one abstraction at a time. And if you have part of the domain, the problem you don't understand, there is some level of uncertainty, tests are really great way to explore that uncertainty. So if you're uncertain about something, if there's complexity, try to think of it in terms of scenarios or examples instead of rules. And before introducing new abstractions in the code, try to take the perspective of a code reader. How much cognitive load we need to understand the code? Do we gain anything by introducing more abstractions in the code? Or do we actually require more cognitive load from the reader to understand it? Keeping things in one place, perhaps it's easier than splitting it up. Perhaps it's not, but consider the perspective of a reader. Not always easy to read your own code. Maybe a teammate can help you. So these are all the questions. Just what I said. So let's go back to our senior developer and accepting a new team member, new junior. So this talk was all about doubting the principles. Is there a different way to do it? Do not be too dogmatic. Why do I value these principles? What is the real reason behind? So, and every project we embark on is a chance to evaluate the applicability of the principles. And if you're lucky, your team will challenge you. Now, and you don't have to be too serious. Well, next time you get in a situation, somebody challenging your principles, well, you say, well, these are my principles, and if you don't like them, I have others. This is a great quote by Groucho Marx. So that's about it. If you're still curious, there is a workshop tomorrow on workshop room 2 on practical domain-driven design. We're going to cut straight to the core of it without too much jargon and difficult terminology. We go straight to the modeling. It's a workshop room 2, limited seats. It's not a room 2 here, but it's on the other side where you leave your jackets. So please consider joining tomorrow or get in touch. Thank you.